Hello and welcome back. Our last video, we were able to look at a graph theory or using a graph approach to be able to solve what we call the shorter distance between cities or towns. And this was the algorithm we were able to come to write for that particular problem. And they were in 3 steps. Select a vertex, connect it to the nearest neighbor. Then number 2, you find an unconnected vertex. You also connect it to the previous unconnected vertex. And then the last step is repeat step 2 till you've connected all the other 6 remaining vertices. Now we want to take an example. So first of all, we want to learn certain basic instructions or basic rules in writing simple algorithm. Now, please remember, I'm not teaching programming. So these are basics. I need this in my mathematics approach to what is behind our algorithm. So during your programming class, you'll be taught in detail these things. So this is just about 3 or 4 syntaxes that I want us to be familiar with. The first one is assignment statement. Then we come to a compound statement. Then we look at iterative statements. Then we look at conditional statements. These are the statements I want us to look at and take an example. Okay, so let's look at what an assignment statement is. Now, in my slide, I've explained our assignment statement to simply be something that is assigned, a value is assigned to a variable. Now, normally what we do is that this symbol you see here, colon and equal to, is what we refer to as an assignment statement. Just watch my mouse. So on the left-hand side of this symbol will be a variable name. And then on the right-hand side will be an expression. I'm going to give you examples to explain this better. So the assignment statement is actually used to assign expressions to a variable name. So on the left will be a variable name, and on the right will be an expression. This is an example. I'm going to take this in my Excel sheets later on, but this is how the question is. We are supposed to use an assignment statement to solve this problem. What is the problem? I have 2 numbers. The first number, the first number is called first. The second number is called second, incidentally. And you're supposed to pick these 2 first numbers and then add them and assign the result to a variable name called sum. Okay, so in my algorithm, I have a simple instruction. Begin, I will input the 2 numbers, first and second. And what am I supposed to do? I'm supposed to add them. So the next variable name is sum. And sum is supposed to take the addition of the first and the second. Like I said, I'm going to explain this more better in the Excel sheet, but take note of this problem. We are going to really take an example to do this. Now, the next is a control statement. I'm taking all the instructions, then we go back and work on this. What is a control statement? Now, control statements helps us to be able to control the program or the algorithm you are writing. And there are 3 main types, okay? They are the compound ones, there is a conditional one, there's the iterative ones, okay? What is a compound statement? A compound, you know what a compound name is, long name. So when you write an algorithm and use a compound statement, it means you have statement 1, statement 2, statement 3, statement 4, up to n number of them. And for the program to run, you must execute all these statements as a unit. Statement 1 followed by statement 2 sequentially. And it's only when statement n has been executed before you will get a result. Again, we will see examples of this later on. Now then we have, so there's an example like this also in my slide. Now I'm using, this is an example of a compound statement because you see that I have statement 1, statement 2, statement 3, statement 4. I'm looking at the lines of this algorithm, and there are 4 lines, just like there is statement 1, statement 2. So here my n here is 4. Again, I'm going to explain this in an example in the Excel sheet. And what are we supposed to do? The algorithm says take 2 numbers The first number is called 1. The second number is called 2. Now, when we input this into the program, we are supposed to swap the numbers. So at the end, the number 1 will actually have the number 2, and the number 2 will assume the number 1. So in my algorithm, the simple instruction I'm given is that initially input these two numbers or two variable numbers, 1 and 2. Now remember, because I'll be swapping their numbers, I have to first of all store the first value in a temporal memory, which I'm calling store. So remember, if 1, let's say 1 is 7 and 2 is 6, when I say give the number 6 to 7, then what is going to happen to 7? That 7 will disappear. So what I need to do is to store, first of all, the first number in a temporal memory. So that's what I've done here. So take 1, store it in store. And then now come and take 2 and give it to 1. So immediately I take the number 2 and give it to 1, the value of 1 will disappear. But remember, I've stored 1 in store. So now I'll come and ask store to come and give it value to 2. I know if this is the first time, this may sound a little bit cumbersome, but like I said, go over the video and look at the examples I'm going to do and see whether it can make meaning of what I am trying to explain. Okay, so the next rule is a conditional statement. Now, there are so many conditional statements in algorithm, but I'm going to pick only 2, what we call the if and then condition, and then if then else. Okay, now we use this condition when there are more than one possible solution to the command we are given. For example, let's say you are booking a hotel. Okay, now when you call the reception, the first question he will ask is what type of room do you want? You say, okay, double or maybe single. Then you want to find out who is staying there. Is it a male or a female? So you see that in this particular question or in a particular statement, I may have to choose if male, then do this. If female, then do this. That's why we have if this, then that. Or anything, for example, we want to find a square root of 4. If I ask you to find square root of 4, most of you will say the square root of 4 is 2. But in mathematics, square root of 4 is plus or minus 2. So if it's positive, put 2. If it is negative, put minus 2. This is why we need this conditional statement, and we use it in programs when the output may be more than 1. Okay, now, so there's an example here. I don't know how many of you know what an absolute value is. An absolute value, what it does is that any time you use an absolute value, whatever the result is, if it's positive, it will remain the same. If it is negative, it will produce the positive value. So this is an example. Let's say I choose a value of n. I don't know what that n is. If n is 10, then it will check. If n is less than 0, okay, then let absolute value take the value negative n. So for example, let's say n happens to be negative 10. Because absolute value only will produce positive numbers, it will check 10 is less than 0. So what would this program do? It will take the 10, negative 10, and negate it. So negative will make this positive. Okay, but if the value of n is already positive, if n is positive, which is where the else comes in, then just produce that particular value. Okay, so this is when you use the if and then. There's one more rule, what we call the iterative statement. This is when you have a long list of rules or long list of sequence of information. For example, add 1 to 100. Okay, so you say x is equal to 1. Then it will add to 2. Then you say let x be equal to 3. Then 3 will be added to the 1 plus 2. Then let x be equal to 4. Then it will add to 1 plus 2 plus 3. You see, n will continue till it gets to 100. And because n is a value which is long, we will use what we call the for to do loop. For I running from 1 to 100. So it means when I is 1, do this. And the for to do loop, what it does is that anytime you use I will increase by itself automatically. The other conditional statement is while there's do the following. So these are the basic building blocks to writing simple algorithm. I told you earlier, I am not here to teach you programming. I need these simple syntaxes in the mathematical examples I'm going to show you in Excel. So let's pick example for the first problem that we shown, assignment statement. Okay. So here we go. Now, so I'm repeating the definition of assignment statement. I said assignment statement, what it does is that it takes an expression on the right and replaces it with the variable. It stores it in the variable name. Okay, so remember the first example we saw in the PowerPoint. Remember I said there were two numbers. The first number is called first, the second number is called second. And all you are supposed to do is to use the assignment statement to store the information of first plus second. So this was the algorithm. Okay. Now I want to take an example here and see how this is done. So let's say that I'm going to take the first value to be 7 and then the second value to be 9. So look at the first line of this algorithm, this first line. So line 1, it said input first and second. So I'm going to input the value of first. The value of first is 7. The value of second is 9. Okay? Remember, this first line, there's no syntax or there's no information to do anything to sum. So I will show nothing here. This Excel, I don't want to put anything here. Then I come to line 2. What does line 2 says? Line 2 says that take the value of first, add it to second. So line 2, remember, I'm not going to do anything to first. The value of first is still 7. The value of second is still 9, but it is the value of sum. Remember, sum is now going to take the addition of first and second. So 7 plus 9 is going to give me what? 16. Okay? Now, I don't have any line. There's no line 3. So it means that the output of this program, what has happened? I initially inputted first value and second value. And then finally, I summed the first and the second, and it gave me a value of 16. I'm only trying to explain what assignment statement does. Okay? Now let's take another example. This is quite simple. Now this time, I have an algorithm to interchange two numbers. It's an algorithm to interchange the values assigned to two variables, 1 and 2. So I am taking an example on the right where my variable 1, I'm giving it the number 7, and my variable 2, I'm giving the number 9. Now let's go through the algorithm. Line 1, input the value of 1 and 2. So the value of 1, I'm going to input the value of 7. The value of 2, I'm going to input the value 9. Now, line 1, I do not have anything, any instruction about store. So again, this column, I'm not going to do anything. And I go into line 2 of the algorithm. This is line 2, or the second row. What do I see there? Now it is asking me to take the value of 1. What's the value of 1? The value of 1 is 7, and then give it to store. So the rule to the game is that if in a particular row of the algorithm, if you do not do anything to the column you are on, I mean, I'm not doing anything to value 1 anymore in row 2. I'm not doing anything to value 2. All I'm doing is that I'm taking the value 1 and giving it to store. So it's only here that the value is going to, store is going to have a value. So all the information previously stored in 1 and 2 will be repeated. Okay, so under row 2, 1 will still have the original value 7, 2 will have the original value 9, but it's only the value of store that is now going to assume the value of 1. So store is going to be assigned the value of 1, and 1 happens to be 7. Remember what this algorithm is doing is to interchange the numbers. And I explained in the slide that because if I say give value of 1 to 2, then 2 will lose its number. So first of all, I have to store one of the values of the variable in the temporal memory. So I'm calling it store. So that's why I'm picking the value of 1 and giving it to store. So line 3, what am I supposed to do? Take the value of 2. So the value of 2 here is 9. and give it to 1. So now 1 will no more be 7. It's going to take 9. Now, I haven't done anything to 2. So 2 will still remain as 9. And I haven't done anything to store again. So store will still be 7. I hope you follow. Then we come to line 4, which is this last line. Now it's now asking me to now take the value I've stored in the value variable store and give it to 2. So store has taken the value of 7. I'll give it to the value of 2. So this 2 will now take 7. And what will be the value of 1? It will take the previous value, which is 9. Okay, so now you can see we started with 1 to be 7 and 9. 1 is 7 and 2 is 9. And we ended up 1 now being 9. And now this is being 7. We have swapped, we have changed, we have interchanged the variables. Now, so what assignment statement helped us to do is to do the swapping of variables and values stored in variables. Okay, I'm going to take another problem. I think this may be my last problem for now. And I'll share with you where to get more exercises on this. Now, this time round, I am going to make use of assignment statements, okay? And followed by iterative statement. Why am I saying iterative statement? Now look at the algorithm. The algorithm says that compute the sum of the squares of the first n positive integers. Now I hope you know what an integer is. If you don't know, an integer is a positive or a negative whole number, okay? Positive or negative whole number, including 0. So they are saying take all the integers, take all the positive integers. So it starts from 1, square it and sum it. So 1 squared plus 2 squared plus 3 squared. Now that mathematics is what this algorithm has been written to do. So begin. It says sum. Let's sum, assume the value 0. Now the reason we do this is that we create a storage space of where we will be keeping the addition of 1 squared, 2 squared, 3 squared, 4 squared out to n squared. So we decide what our n is and we start squaring and summing. So I initially, we normally say initialize the variable. So sum is initialized, or I assign the value 0 to sum. So if there used to be a value in sum, by doing this, I'm able to make it 0. And then I'll start my counter. Remember, I'm supposed to square the positive integers. Integers are infinite set. So when I come to my table, I'll choose n so that I can do this manually for you to see. So I'm going to pick I. If I choose n, for example, to be equal to 5, it means I'm going to take I from 1, 2, 3, 4, 5, and see how the table will generate the values. So here we go. I take the value of 1, and in the algorithm, then we now will have to take 1 and square it. You see 1 squared. So 1 times 1. That is where now I have to create a space where I'll be storing the squares of the numbers. So I'm using the variable name j. So j will take the value of 1 and then multiply by 1. Okay, now I have squared 1. Remember, when I go to 2, I'll take 2 and square it. 2 times 2. That will give me 4. I have to come and add 2 squared to 1 squared. So what I need to do is to create a line of the program where it will pick the original value of sum. Remember, sum was 0. So sum of 0 will be here. In this program, this sum will be 0. And then the j I've just computed, which is 1 squared, will be here. So 0 plus 1, then it will store it here in this sum on the left-hand side. Then I will go to 2. Now, this will become clearer if I start working on the table here. So please just be patient and see how this is done. Now, so look at the variables. Like I did for the previous, I look at line 1 and now I'll place the values here. If there's nothing, there's no instruction for a particular variable, I'm going to leave it blank. So line 1, I'm going to initialize sum. So here, I'm going to put 0 here, okay? There is nothing being said about, there's nothing being said about I, j, and n. Well, we are told that let's take the value of n to be 5. So I'm going to take n is equal to 5. So I'm going to check when I execute. Now, so sum is 0. I takes no value, j takes no value, and we haven't checked for n because we have not imputed I. Now, then I go to line 2. It says let I take the value 1. So remember, sum is going to take the value 0. Well, let's go to I first. I takes the value 1. Okay, let's go on. And then what's going to happen to the value of j? Now we are in when we pick the value 1, we have to do something to that value 1. We must square it. So we will come to j. So j will take the value 1 times 1. What is 1 times 1? 1 times 1, which is what the algorithm is saying. 1 times 1. 1 times 1 is going to give us, I'm just doing this for explanation's sake, we'll give you 1. Okay, that will be j. So j is now 1. Now, then we're going to find out what's the value of sum. I'm taking this, so this thing is a loop. So I'm going to, when I take I is equal to 1, I have to make sure I run through up to here. That's why I'm still on this line. Now the new value of sum is now going to take the previous value of sum. So here, this sum is going to take, remember, sum is take the value of sum, which are at the top, which is 0 plus 1. And now the new value of this is going to be, this is going to take the value of 1. I hope it stays there. Okay, let's all accept this. Now, so it means that now the new sum, I should put this here rather, on the same rule, sorry. Okay, so sum is now here. So in line 2, we choose the value of I, we computed the value of j, and now we have a new value of sum. And then we check, is I, look at the condition, is this I, we come back to the loop, is this I equal to 1? Sorry, is this I equal to 5? Look at I is 1. Is 1 equal to 5? If it is equal to 5, we stop. So I is not equal to 5, so I'm going to put here no. Okay. Now, so then I will automatically increase by 1. I told you the for to do loop, what happens to when you use for to do, for one running to something, do this, it means that I will automatically increase. So we'll come back to the second line here, line 2. I will take the value 2, it will increase by 1. And then we come back here. When I is 2, j is going to take the value 2 times 2, which is 2 times 2. And 2 times 2 will give you 4. And what will be the value of sum? Sum is now going to take the previous value of the sum, which is 1. Now remember, when we executed this, we got 1. So okay, so I'm saying that this particular value of sum is going to take 1 plus the j, which I've just computed. Remember, sum is sum plus j, and j is now 4. And so the next value is going to be, bring space, 1 plus 4, which is equal to 5. Okay, so now we are going to check, is 2 equal to 5? Again, no. Then I come to I, will go to 3. Okay, 3 will increase, will multiply by itself. 3 times 3, that will give you 9. Then we are going to come to sum. Sum is going to take the previous value of sum, which happens to be 5, add it to the 9, and then that will give me 14. Okay, then we check, is the I, the value of I, supposed to be checking this, is I equal to n, which is equal to 5. That's what we are checking. So is 3 equals to 5? Again, no. Then we come to I goes to 4. Oh, by now you are following. This gives you 4 times 4. That is j times, j is equal to I times I. That gives you 16. Then we will now evaluate the value of sum. Sum is going to take the previous value of sum, which is 14, plus the 16 we've just calculated. And that gives us 30. And then we are going to check, is 4 equals to 5? Again, no. And the last row is going to take us to that. Now I is now going to take the value of 5. I is increasing by 1. That gives you 5 times 5. That gives us 25. Okay. Then we come to sum, and sum is going to take the previous value, which is 30, plus what we've just calculated, which is 25. And that gives us 55. And then we check, is I equals to 5? Yes. So it means that we are going to output. What is our output? When your I is equal to n from the algorithm, when I is equal to n, that means that you have executed your program, you output sum. So we come here. Oh. So what is going to be the value of sum? If you take your time, look at the values. Sum was 0. It took the value of 1, it went to 5. Okay. Let me do it this way. 0. I had 0. It went to 1. It went to 5. And it came to 14. 14. And from 14, it went to 30. And then we ended up at 55. This was for n. N is equal to 5. You can do this to 10. Now, if you take your time, like I said, and you find 1 raised to the power 2, okay? 1 squared, and you realize that the answer will be, 0 squared. 0 is not a positive number, but we want to just show how this algorithm really is working. 0 squared will give you 0. Now, what is 1 squared? And then what is 1 squared? 1 raised to the power 2. And that gives you 1. And what is, so if you check 0 plus 1 will give you 1. Now what is 2 squared? 2 raised to the power 2 is going to give you what? 4. Now what is 0 plus 1 plus 4? It will give you 5. So virtually all we are doing is taking the integers and squaring them, positive integers. This will give you 9. Okay, so all you are saying is that this is 0 squared plus 1 squared plus 2 squared all the way up to plus 5 squared, at least for what we have executed. Okay, now you have on your calculator x squared. That function on your calculator is what this algorithm is doing. Okay, so ladies and gentlemen, this is the example in my PowerPoint. Okay, now I'm going back to my PowerPoint. I'm going to summarize, and then I'm going to show you where exercises can be found. You see that I've written your group questions. And I told you in my first lecture that I work using group approach, peer-to-peer group work. Okay, so in summary, basically we looked at from the beginning, we saw the definition of discrete maths. We saw what modeling is. We use a graph theory to be able to explain how you can move from one place to the other. Then we define our algorithm by using graph approach. And then we wrote a simple algorithm to be able to connect 6 towns. And we looked at what a pseudocode is. Now, when we came to examples, we looked at 4 different statements or syntaxes that help us to do the assignment statement, control statement, and a compound statement and conditional statement. Compound statement will give you conditional iterative. And these are the control statements that we use. Okay. Now, so basically, these were the things we've done so far. The last part of this lecture is to look at that you can make meaning of all this lesson I'm teaching you in this first lecture. Now, so if you look at this, I have 10 questions in this particular Word document, and it will be on the model page. And for the beginning, those of you who cannot send model page, I'll send this to the reps and they can make it available. So you see group 1, you have group 1. This is a question I did a few minutes ago. Now, group 2, this is your algorithm. Group 3, that is yours. Group 4, that is your question. Group 5, there you are, all the way up to the 10th question. I think I have up to group 11. Now, if you are more than 11 groups, if you are more than 10 groups in a class, then 11 will do group 1 again, 12 will do group 2. So take note of that. Now, so what do I expect from you when you pick these questions? Now, you remember that when I took the algorithm, I drew a table on the right in my Excel. Follow the same trend. And this should help you to know what to do. I've written here 5 instructions. Now, sometimes you ask yourself, how many columns will be in that table? The table of output will help you to know what the algorithm does. So first of all, you look at the number of assignment statements. Please take note of it. The number of assignment statements. Now, this will help you to know how many variables. So if I have assignment statement 5, that will help me to know how many variables. Okay, remember, look at this. Here I have assignment statement here. You remember, in the definition of assignment statement is on the left-hand side is a variable. So it means it will tell you how many variables will be in the table. So sum is a variable, I is a variable, J is a variable. We've already seen sum as a variable. So I mean your table should be made up of sum, I, and J. Now let's see, for example, this next group question. Here, I have F is assigned a value 1. So F is a variable, I is a variable, and then F again. So it means F and I. One more example. In this question, I have I as a variable because it's assignment here, J as a variable, and then I think I and J, M and N is given. So these are fixed values. So the more assignment statement you have, look at this one. First is a variable, second is a variable, next is a variable, and then you have what you call first, second, and next. These are the variables. So I'm saying that if you go to the top, identify how many assignment statements are there in your algorithm, in your group question. That will tell you how many variables you have. Then you see the table I created here, sum, I, and J, because I happen to have how many assignment statements? 4. Then it means that how many variables? Sum, I, and J. Then the next third instruction, determine the constraint. What's the constraint? Every algorithm runs for some time. And how do you identify the constraint? When the iterative statement, the for to do loop or while do this. So you see this one, this problem says that I start from, this is the iterative statement. I start from 1 to n. So this will tell you how long this algorithm will run. And in the question, normally n will be given. So n is equal to 8. So even though in my presentation, I did n equals to 5, group 1. In this question, you're supposed to continue to 8. So follow the trend and continue till you get to 8. It's a very simple algorithm. So that would be step 3. And step 4, draw the table of outputs. This is all I mean by a table of output, this simple thing. This thing you're seeing here, the table of outputs. And then step 5, what does this algorithm do? So when you finish and you get your output, for example, in this problem, I happen to get 0, 1, 5, 14, up to 140. If you copy these values and place them in Google search, and the number separated by a comma, Google will describe what this is doing. If you don't know, if you can't use Google, I'm going to type here. So those who watch this will see this. Wolfram, www.wolframalpha.com. You can type it here. This is a mathematical search engine, and it's the numbers you are getting, the output of numbers you are getting will be described by this math search engine. So ladies and gentlemen, this is what my first lecture really looks like.
For more information and also to reach us, please contact the numbers on the screen. You can also reach us through our social media handles displayed on the screen. Please do like, follow, and subscribe to our social media handles. A Softek IT Consult. Innovative solutions with the difference.